Hey, hey, hey. We've made it to the last lecture for Monday's lecture. I've been working on it all day. I know. And you've been working on it all day too. Good for you. All right, so what do we have left in special senses? We have equilibrium. And for equilibrium, equilibrium is going to involve the inner ear, like before, but it's not the cochlea. The cochlea is going to be sensing hearing, and we had said, we've already talked about how that works. Now, the other parts of the inner ear also utilize these stereocilia, these so-called hair cells. And remember, we had said, what happens with the hair cell? When it gets bent, it opens a non-selective ion channel, and the fluid that is surrounding the hair cells has a high concentration of potassium, so the potassium ions move in. It causes the nerve to send a signal saying, to form an action potential. Well, we have the same thing going on here, only the hair cells are sensing what we call equilibrium. So whether you are standing upright or laying down or upside down, that would be static equilibrium. And static equilibrium is sensed in the vestibule. Now, the vestibule is, of course, this center part of the inner ear, and we have two structures there. We have the utricle, which is horizontal, which is vertical rather, and then we have the saccule, which is horizontal. And in each of these, what we have is we have an otolith membrane over the top. Otolith means rocks, stones. The little stones that are in there are calcium carbonate crystals, and they're going to push down on the hair cells, and depending on if you're standing up, laying down, upside down, they're going to move the hair cells in a way to where it sends action potentials to your brain, and you will know, you say, oh, I'm standing upright, or if you're on your head, it'll be the opposite, and they'll be moving these in a different manner. And similarly, if you're lying down, because the utricle is vertically, it's sort of on the side of the wall in the vestibule, and so when you're standing upright, the hair cells are deflected down. Horizontally, we have the saccule, and when you're standing up, they're not bent. The hair cells are not bent. Okay, at the base of each of these semicircular canals, we have a wide area called an ampulla. So the ampulla is a location where we have some structures called the crista ampullaris. And what they are is they're like a little finger-like structure that is sticking up into these swollen areas at the base of these semicircular canals. And they have hair cells in them. And what happens is the semicircular canals are filled with water, or fluid, not water. They're filled with fluid, and when you are moving, when you're driving down the road and you go around a curve, or you're running and you make a hard cut to the left, the fluid is gonna press on these crista ampullaris and bend them one direction or the other. And that's going to send a signal to your brain saying you're going to the left or you're going to the right. Is there anything else I need to say? I think that's it. I think that is the final installment for special senses.